Hi everyone, welcome to questions on stereoisomerism. Now the first question here is asking why pent-1ene does not show stereoisomerism. Now for this question you need to know what stereoisomerism actually means. And this goes back to your definitions. This is why definitions are very important. If you don't know them, you need to make sure you go away, get them committed to memory. So it's asking you for a definition, not in a direct way, but kind of in an indirect way, applying that knowledge. So an answer for this here, why pent-1ene does not show stereoisomerism, well, we can see that on the end of the structure they've given us there, that one of the carbons, so on that very end carbon, has two of the same group attached, there'll be two hydrogens, so therefore you can't show different stereoisomers. Now, there are structural isomers of pent-1ene that show cis-trans, and we need to draw those structural isomers. So hopefully we have structures that look like that there. Make sure that cis and the trans are there, and hopefully that should all be okay. Here we have our second question. We have two double bonds labelled 1 and 2, and we've got to decide which row A through D identifies as E or Z. So for this first one, let's go for number 1. We have to look at each carbon and assign which one has priority, which of the bonds coming off it has the priority. Now this would be this particular one here. Now the other one would have a hydrogen coming off it, but we don't tend to show those in skeletal. We don't show hydrogens there, so that's why it's looking like it's not bonding to anything else on that side. It is, but it's a hydrogen which doesn't get the priority. Then we look at the other side. So initially we looked at this carbon here, and we decided that one there in yellow was the priority. This is the other carbon that's there. So we need to look and see which one gets priority. Now both of them are bonded to carbons, so there's no difference there. But then you have to keep on going until you eventually get a difference. And that would therefore mean that this particular route here would get the priority. So those two there are on opposite sides, so that would be E. So the double bond for 1 would be E. So that then narrows down it to the answer to either A or C. So it can't be B or D. Now we look at bond number 2. Let's just get rid of that there. Now for this one here, again, same principle applies here. We have our two carbons. So one carbon is there and then one carbon is there. We then need to look at assigning priority. Now for assigning priority, let's go for the left hand side one, we would have, let's get rid of that there, just so we can see things a little bit more clearly. We would prioritize this particular carbon here, or this particular route, as again we're not showing it, but there is a hydrogen there, but that doesn't beat out the carbon, so that gets priority. On the other side, again we're not showing that hydrogen bonding off, but it doesn't matter because that would get the priority there. So again, they're on opposite sides there, so again that would be E. So 1 is E, 2 is E, so that leaves us with C there. And we have our final question here, cyclobutane, unsaturated isomer that are alkenes. To start with, state what's meant by the term stereoisomer. Well, again, definition is very important. Same structural formula, but different arrangement of atoms. Part 2, draw the two stereoisomers. Cyclobutane, we need to know that it's C4H8. So we need to make sure we have our double bond in there. We're told that they're alkenes. So we need C4, so we've got 1, 2, 3, 4, and then 3, 6, 7, 8. Yep, we've got the right formula, and hopefully have our two different stereoisomers there. Okay, that will do us for today on questions on stereoisomerism. See you next time.